Hey VaRhona, let's take a look at these questions that you sent me. First one here, we have 2y to the 1/3 raised to the power of 2 over y to the 1/6 exponent. So what we're going to do first is our exponent laws. So what I'm going to do is each little part of this, the 2 is going to get squared, and also the y to the 1/3 is going to get squared. Okay, so 2 squared, I'll just write it out, 2 squared, and then for the y here we have y to the 2/3. And the reason why, if we think about it, we have 2 over 1 times 1/3. I'm just doing the exponent part right here. So 2 times 1 is 2, and 1 times 3 is 3. So that's where that comes from. I'll erase my marks, and on the bottom here we have y to the 1/6, the exponent. Now 2 squared is 4. So in the interest of saving space, I'll just write that in right now. 2 squared is 4. And now what we're going to do is we're going to look at these terms right here. So we're going to divide two exponents with the same base. When we do that, remember, we subtract the exponents. So we're going to have 4y, and our exponent is going to be 2/3 minus 1/6. Now whenever we subtract fractions, we need to have a common denominator. So I'm going to multiply just this first fraction by 2 over 2, and that will give me 4/6. I'm going to rewrite my second fraction, 1/6, and now I can subtract this. So that's going to be 3/6, which reduces to 1/2. So this would be 4y to the 1/2. That would be our answer right there. Okay? Just punch that in and we'll see what we get. And there we go. So that's that first one. Hope that helps. The second one, I'll just jot it down. We have 3 to the 5th root of 4 plus 2 to the 5th root of 4. And we're asked to add or subtract terms whenever possible. Now, think back to algebra. Whenever we had like terms, like 2x plus 3x, well, what we would do if we're combining like terms, adding or subtracting, we would just simply add the coefficients, so 2 plus 3 is 5, and the variable just kind of comes along with that. We're not multiplying here or anything like that. We're just combining like terms. We can apply that same idea to roots. So here, we don't have like terms, but we have like roots. We have the 5th root of 4 and the 5th root of 4. Both of these terms here have the same like root, and we're going to combine them. We're going to add or subtract, in this case add. So it's the same approach. We're going to add the coefficients, so we have 5, and then the root just kind of comes along for the ride. Okay, so that would be our answer right there. And again, note that approximating this with a calculator, you could punch that into a calculator if you have a high-powered one and approximate it to a decimal, but that is not the exact answer. This is the exact answer right here. So let's type that in. So we're going to type in 5. We're going to hit our nth root. I'm going to put a 5 up here for the index, and I'm going to put a 4 right here, and that is our answer for that one. Next one, we have the cubed root of 625 times x to the 4th, and that's all underneath the radical sign, and we're going to divide that by the cubed root of 5x. So, because we have the same index here, we have the same cubed root kind of thing going on, we can divide these things. So let's focus first on our whole numbers, and then later we'll focus on our x's. So I'll color those in blue. And another way that you could rewrite this, we could write this as the cubed root of 625 x to the 4th over 5x. Okay, this means the same thing. Because we have the same root here and here, we could rewrite it like this. It's just kind of semantics at this point, but let's divide 625 divided by 5. And that's going to come out, punch that in your calculator. That's going to come out to 125. And now we'll do our exponents here. We have x to the 4th divided by x to the 1. So that is going to be x cubed. Remember, when we divide two exponents with the same base, we subtract the exponent. That's what we're doing here. Okay, so now what we need to do is we need to figure out what this is. Well, the cubed root states that we're going to have a number times a number times a number, and that should be 125. That's what we have to come up with here. Another way to think about this is if we do a prime factorization on 125. Think about two numbers that multiply to give me 125. Let's go 25 times 5. Okay, 5 is a prime number. 25 can be broken down again. And I'll carry this guy down here. So 5 times 5 times 5 is 25. So the cubed root of 125 equals 5. Okay, it's just the opposite of the above operation we did. So the cubed root of 125 is 5. And the cubed root of x cubed, because this is raised to the power of 3 and we're taking the cubed root, that's just going to give us 5x. So that's going to be our solution right there, 5x. And you kind of hit on that right there. Okay, so I hope that helps. If you have any other questions, please let me know.